Second part of our discussion is that, okay, suppose I give you a task of learning. So let's just take one task and let's just divide that task into learning tasks and reasoning tasks. Okay, for example, the first task is to develop a natural language processing NLP system, natural language processing. Okay. Now, this is an interesting observation. Jihad has actually just pointed out. And this is actually has led me to the second part of my discussion. Thank you, Jihad. He has actually written in the chat and he has said that, okay, AI is the system that can learn and reason like humans. Okay. Now, ideally, that is what we want. Okay. Ideally, what we want is that they should learn and they should reason like humans. That's the ideal situation. Okay. Now we are not living in an ideal world. Okay. So what we want is that, okay, understanding uh understanding how a human brain works and then try to perform some tasks and reasoning tasks that a human can actually perform becomes really difficult at times. So what we do is that we modify this definition a little bit. Okay, so ideal definition is that the learning and reasoning should be done as humans are actually doing. Okay. Okay, so but what we have done or what we have modified, because that's a difficult task, because in order to understand that how humans learn and reason, you have to understand that how the brain actually works, because then you will develop models that behave very similar to brain, and then you will develop those systems. And because of the limitations of our scientific limitations and observational limitations, we are unable to completely understand that how human brain actually works, right? It's just a very small percentage that has been discovered about the human brain. Therefore, developing a comprehensive system that learns and reasons like human is difficult. Okay, so what do we want? How can we modify this? How can we change this? Okay. How can we change this definition or modify this definition so that we can only remain within the domain of our non-knowledge. Okay. So whatever we know, we remain within the knowledge of whatever we know. So in your opinion, anyone can contribute in this, that how can we modify this definition in order to develop systems that do not really require the complete understanding of that how a human actually operates. So how can we modify this definition? Yes, I'm waiting for an answer. Okay. So what I want is I want the definition to be modified in a way. So the complete definition is that an AI system would learn and reason like humans, right? And as I told you, that may not be absolutely possible. The reason for that is that understanding that how human brain actually works may not be possible, because so far we have only been able to discover some percentage working that how a human brain actually works. We have only been able to identify or understand some very small percentage that how a human brain actually works. So developing a system that completely behaves, learns, and reasons like human may be a little difficult, right? So therefore, a a small change or a change is required in this particular discussion or in this particular definition. Okay, and what might be that change? Okay, so what I'm saying is, okay, we'll keep learning there, we'll keep reasoning there, but let's say we don't want to mimic humans. Let's say, let me put it in this way. Okay. So yeah, go ahead. Yeah, anyone? Okay. So what we can do is that, yeah, you're right, Aish, Mohammed. You're right. Okay. So Musk is also right that he has actually said that, okay, train the machine on large amount of data, but again, complete data cannot be discovered. I mean, you cannot write or you cannot gather the complete data. You will always get part of the data. Okay? You'll never be able to get the complete data. So what we can do is that, okay, a complete AI systems cannot be developed, but what we can try to do is that we can try to develop systems that can have rational behaviors, or in other words, rationality. So we can develop learning and reasoning systems that always result in some sort of a rational decision. Okay, what do we mean by rational decision? Okay, what do we mean by rational decision? Anyone? Okay, so this word rational, what would this mean? Okay, rational would mean that whenever the system will give you an output, that output should always be correct. So there is no room for mistakes. That what rationality means. Okay. So what we do is that we would look for rationality. That means that whenever an output is given by an AI system, that output should always be correct. We don't want mistakes to be done by AI systems. Right? Am I clear? So that's why we are now modifying our definition. We are modifying our definition of AI. We are saying that, okay, AI is a system that is able to learn and reason and generate rational decisions. Okay. So we have deliberately said that, okay, human like is, for the time being, is out. Okay. So then now we have like two different definitions here. One is in which human mimicking or behavior like human is the essential goal, and the other one is rational decision is the essential goal. Rational decision means that always correct decisions. Okay, so on one side we have got humans, H, on the other side we have got rationality, which is R, and we all know that humans are not always rational. I mean, humans do make mistakes. Okay. So when I'm saying that we develop a system which is mimicking a human, that means that in totality it mimics a human being, right? That means the system is also able to, uh, let's say, make mistakes, because humans do make mistakes, right? So if you learn something, yeah, so you learn like humans. So that means that if you develop an autopilot system, you all know an autopilot system, that if an automatic landing of an aeroplane is to be developed, and you develop a human-like system, what would that mean? That would mean that humans at times do make mistakes, and that means that crash landing might take place, because humans can also make mistakes. So what you want for let's say for an AI system is to be an error-prone system. Okay? And that means that it should always give you a rational decision. So you can't afford to have a system that can make mistakes. Okay. So therefore, the practical definition, or the practical world, in the practical world, the definition of AI actually moves from human-like systems to rational systems. Okay. So now there is a comment. Let me see what Muhammad Aish has to say. Okay. So AI is making mistakes. Okay, now this is a very interesting question, Muhammad. Thank you for raising this question. And this question is that, okay, the AI systems are also making mistakes. Now, why the AI systems are making mistakes? Because, well, I'll not answer this question. I'll ask this as a counter question to all of you, that, okay, on one side, we are saying that we want rational system. On the other side, we know that AI systems are making mistakes. And that's what we want to prevent. Okay. That's what we want to prevent. But why can't this be prevented? Okay. Okay. One possibility is that, okay, as Jihad has actually mentioned, you get the wrong data from the humans, or because humans actually collect the data and they might make mistakes. Right. Okay. So that's like one thing. What else? Some humans mistakes of human. Right. Okay. So that's like one. And in another way of saying the same thing, which Jihad has actually said and Ahmed has just said, one way of saying the same thing, right, is that the data that you collect is sometimes, or some of the examples that you get in your data are wrong examples. Okay, or they may not be correct. The data may be incorrect. You may have, let's say, if you have got 100 different data points, and out of those 100 different data points, 95 of those data points may be correct, and 5 of them may be incorrect, and you may not be very aware of those 5. Okay? They might have been entered into your training data somehow. Okay? So there was some error in the data. That might also be because of some limitations. For example, if you are developing a robotic system and you want, or an autonomous car for that purpose, which takes automatic turns, and you place some sensors on it, those sensors might function wrongly. They might give you some junk value, or they might give you some wrong value because the sensor may not be working correctly. Okay. So that might generate an error. Yeah. So that's right. I mean, Musk, you're absolutely right. The reason for that is that you don't have the complete data, and the data you might think is complete may also have some errors in it, or some sort of mistakes in that, or that might be wrong data. And as I told you, one example, that if for example you are measuring the temperature of a room, and that sensor that you have placed in the room that is giving you wrong readings is off by 2 degrees or 3 degrees. The actual temperature is 25 and the sensor is giving you 24. Your thermostat setting of your air conditioning system will not work properly in that case. Okay. So that might be the case. Okay. And that's why, so that's one limitation. And let's assume Okay. I'll share the slides also with you. Don't worry about that. I'll be showing some slides after I complete this discussion because I want to make it more interactive. That's why I'm actually using this whiteboard here. So um, yeah, so one of the things is that the data might be incorrect. Okay, so that's one of the things. What else? Is there any other thing that could that could generate errors in AI systems? One is, let's say, data. You don't have the correct data. What else? Okay, environmental variables around AI systems may change. Okay, but if you are able to detect that change, that should be fine. I mean, the AI system should be able to handle that. Okay, so what else? So what else could generate the error? Okay. Now, Jihad has actually pointed out something which is also important, and that is wrong functions on the programming, right? So, in other words, you have got some implementation issues. Okay. The way you have implemented it, the way you have implemented something, that implementation may have some issues. The algorithm that you are using, the program which you are using, the algorithm that you are using, that algorithm may not be 100%. The algorithm might have some limitations. While you are training an AI system, the algorithm may not have 100% accuracy. Okay. And that's the case even if you have got complete data. Even if you have got 100% complete data, your algorithm or your program may still fall short of 100% accuracy. Okay. And that is measured with the help of some parameter which we call as the error. Okay. So you may have some error while you are developing your system. You say that, okay, your system is 95% accurate. That means that there is 5% chance that an error might get generated. So there are two limitations here. One limitation is on the side of the data. The other limitation is on the side of the implementation. The algorithm is not capable enough to actually generate 100% results. Okay. And that may not be because of the data, that may be because of the algorithm itself. Right? Is this making sense? Okay. Yeah. So shall we move on? If this is clear, then we can move on to the next part of our discussion. Okay. So the last sentence which I said that, okay, you might have some errors in the data. Because of that, your AI system could make mistakes. One thing. The second thing could be that that the that the algorithm that you are using to implement AI, that algorithm may not be 100%. That algorithm may have some limitations. Okay. So if you train an algorithm or if you develop an algorithm, that algorithm may not give you 100% results because of the limitations of the algorithm itself. Okay, so the algorithm would generate error, and that's why you say that okay, your algorithm is now you when you read papers or when you study or develop some models, you will always find out the error in your algorithm, and that error maybe let's say 5%. That means your algorithm is giving you results 95% of the time correctly, but 5% there is a chance that an error might be generated. So is it clear, yeah, Mohammed? Okay, so it's on these two accounts, data and data side. You might have incomplete data. The algorithm could be perfect, but you don't have data, enough data. That's one source of error. The second one, your data may be complete, but your algorithm is not good enough. So both of these things can actually generate some errors. Okay, so this actually completes our discussion on the definition of AI. I'll provide you with the slides. I'll upload the recording of today's session also. And now let's move on to some applications. And for that, I'll be opening some slides, and I'll be showing you some interesting applications of AI. And I'll be stop sharing the screen for a while. And now let's just uh, let me just open the slides, and let's talk about some very good okay, right. Just bear with me for a few seconds. Okay. Yeah. Right. So yeah. So you can see this. Yes, Sanat, if you want, we can create a WhatsApp group so that we can easily communicate. And for that, maybe you can share your numbers, or and or maybe we can create a group and send you an invite here. So Waqar is here. Uh, Waqar, are you here in this group? Yeah. So Waqar, can you please make a WhatsApp group and send the invite on the chat. All right. Yeah, we can share that. Okay, that's wonderful. Yeah, thank you very much. Okay, so